Evaluate integral from negative 2 to 2 f of x dx, where f of x is negative x squared plus 1 for x is less than 0. Pretty sure that's supposed to be x is less than 0 there. And then x greater than or equal to 0 is f of x equals x cubed plus 1 for x greater than or equal to 0. Okay, we can do this. So we're going to break this up into two parts, two integrals. So go from negative 2 to 0 of negative x squared plus 1 dx, and then we'll add to that 0 to 2 of x cubed plus 1 dx. Okay? Then I'm going to switch this around a little bit. X cubed plus 1. Nah, we're good. I'll just start solving. Start solving. So we have negative x cubed over 3 plus x evaluated from 0 to negative 2 plus x to the 4th over 4, that's just using the power rule, plus x evaluated from 0 to 2. So we would have, change colors to show that I'm progressing in life. Otherwise I'd start to feel bad. Going to keep the motivation going. So we have 0 over 3 plus 0 minus negative 2 to the cubed, which would be 8 thirds, minus 2 plus, and then we have 2 to the 4th, which is 16. 2 squared is 4, so 2 squared twice is 16. 16 over 4 will probably just be 4 plus 2, but let's not get ahead of ourselves. 0 over 4 is 0 minus 0, click. Okay? Do some simplifications. 0, 0. Move this over here. 4 plus 2 minus 8 thirds minus 6 thirds. Okay? Feel like I'm moving up in the world. Let's see, there's 2 thirds left over. Yep. And then this will be 18 thirds minus 2 thirds equals 16 thirds. Oh, that seems fairly reasonable. Well, I guess it's only reasonable if it's correct, and it might be. Oh, ha, good for us. Go team. Go team. It's always a little bit worrisome when it's like, oh, am I going to get this? So yes. Backtrack a little bit. So the way I solved this integral, we had a different value of f of x depending on which region we were in. And so when we were less than 0, we had this equation. And so I did negative 2 to 0 of using the first equation, and then went from 0 to 2 of the second equation. And then we solved these just using the power rule. The power rule, as most of you probably know, or maybe not, the integral of x to the n dx, that's an n, will equal, wait a sec, x to the n plus 1 over the reciprocal of 1 over n plus 1, and then there's usually a constant c. But when we have a definite integral with a top and bottom limit of integration, the c is then one subtraction from the other c, and they cancel out. Okay, that is how we approach this problem. Not too bad. Good chance to flex our muscles. And hope this helped with this problem. I will see you in the next one. Go team.